thanks for coming along to this seminar. I know it's getting a bit warm in here after this talk. We're going to have a little break. So almost there for your first break. Today I'm going to talk about passkeys. Just like a quick show of hands, if anyone's heard of what a passkey is or familiar with it, great. Who's created a passkey? Oh, nice. Okay, so my name's Rew Islam. Obviously, I work at Dashlane. I've been there for over 10 years. I started off as an iOS developer, and lately I've been working on passwordless technologies, both passkeys and passwordless ways of signing into Dashlane. Dashlane's been heavily involved in the FIDO Alliance for the last couple of years, and I'll talk about what the FIDO Alliance is a bit later. I co-chair one of the special interest groups focused on credential providers, so Dashlane, Apple, Google, 1Password, LastPass, all the main providers that you may already be familiar with. We're also a board member of the FIDO Alliance. So I want to start with a little story. I don't know if anyone here has any teenage kids or you yourselves are teenage kids. Well, I have one, and he's a bit of an online gamer. He's like 13 years old. Anyway, one weekend I came home and he was like, I can't access my online gaming platform. And I was like, well, either the service is down or something has happened. And he wouldn't tell me exactly what had happened that led to this. So I can understand that he was kind of trying to hide something because he wasn't sure if he'd done something bad. Eventually, I pulled the story out of him. And this is a reenactment, okay? I'll try to read it if you can't read the text. So this is what essentially happened. So this is a platform called Roblox. I don't know if you're familiar with it. It's very popular with addicts like my son. So within the game, you can have you can chat with other gamers, and someone came along. I'm sure a lot of you can already see where this is going. I don't know what the offer was, but it was clearly too good to be true, but it was strong enough for him to start, carrying out some actions they wouldn't normally do, but whatever this guy was offering, it was like really interesting for my son. And for those that have a sharp eye, you can immediately see there's something fishy going on with this URL. Unfortunately, my 13-year-old son, who I have not trained, like we have been trained at Dashlane, into the arts of detecting this stuff, didn't see anything wrong with that. So he clicks the link. He goes to what looks like the perfect landing page for Roblox. I mean, he's my son, so I do give him Dashlane. He's using Dashlane. And if we notice, Dashlane is not trying to autofill the password because Dashlane has an idea of origin matching. It understands that the credential that my son has for this site has a specific origin, and that origin doesn't match up here. And in fact, Dashlane would even try to warn him if he tries to copy and paste, which is what he does next, because he's smart. So he goes to copy and paste, and for most of us, it's obvious here, but I think even for non-technical users, they'll be like, well, it's obviously the Roblox website. I mean, there's nothing, it's slightly different, but so yeah, I was hoping like my son would click don't trust here, but he doesn't. He hits trust and paste because he wants whatever he's been promised. He loses his account. So when I explained to him what happened, he did actually like shed tears. I was very sad for him because, he clearly been building up this character or whatever, smashing the mouse button for hours on end, building points, feeling proud of his character, and it was all gone. I told him, look, that's it. I tried the recovery mechanism. Roblox, unfortunately, isn't the best service for recovery. There was no recovery happening. So what the attacker did, spearphished my son, and then immediately changed the password, changed the details. And I guess there wasn't any money on the account. So, I told him, look, you haven't lost any money. You've lost a bit of ego. But that person could then sell that character, I imagine. He had a lot of points. He can jump straight into the game, whatever. But that was just a story of like a real attack. And, nothing crazy was lost here. But if you work at a company, you probably get these sorts of emails. And this is where the trouble starts, because it's almost exactly the same kind of thing. You're just hitting a link, going to the site, filling in credentials, and boom, as Olga had explained earlier a couple of hours ago, bad things happen. And there are great tools out there for you to learn about, how to do this yourselves if you want to get into the phishing game. MFA, 2FA is good, but it's not good enough because a lot of those mechanisms are also phishable. And in fact, the latest version of Evil Gen X actually caters to bypass two-factor mechanisms. So what can we do? Well, first of all, let's have a look at why passwords suck, because 2FA is just a patch on the fact that passwords are crappy. And so there are three fundamental reasons related to FIDO and passkeys why passwords are crappy. The first one is if you're not using a password manager, you're using your brain, which is incredibly powerful. As we've had many conversations this week about AI, our brains are still kicks AI's butts in a lot of ways, but one way it doesn't kick its butt, well, software's butt, is generating random and remembering random passwords. We generally come up with really bad ones if we do it ourselves. So that's the first issue. They're weak. All the hackers know what they are. They can test them. You're done. The second thing is, like my son, you get links, you click them, and they look like the original site, but they're not. They're a phishing site. And you go in and, you're just doing your everyday, you're busy, you've got to get your work done. You need to quickly send the CEO that report, that RTO report, or whatever it is called. And, and that's it. Now the credential's gone. And the third thing is that not so prevalent, I guess, but, servers get pretty well. A lot of servers gets breached. A lot of services have too much valuable information, sometimes specific to authentication, which allow them to then go and do bad things with that data. So those three areas are essentially what passkeys solve for. And they also solve for 2FA because of these issues, you need that second factor because passwords are so weak. So I'll quickly try and describe what's going on here with a passkey. Instead of the user typing a password, they will use what's called a passkey provider to do the work for them. So that piece of software, whether it's Dashlane, Apple, Microsoft, Google, or any other passkey provider, will actually in the background, without the user having to do much, generate a key pair. This is public key cryptography. There's a private key and a public key. And the private key is essentially the same value in terms of the secretness of the password. It's the thing that you need to protect. And that's typically what the passkey provider is doing. Public key goes to the API, goes to the website. And that anyone can have, that has no security value. So if the server gets hacked, that key is of no value. And in the middle, the actual domain is now origin bound to the passkey. We saw that you could origin bind a password, but a password is just a bunch of characters in a field and you hit go and it's gone. Here, the software will prevent you to use that passkey on a phishing site. So that's essentially the phishing resistant part of a passkey. And that's what makes it all magical. So as I mentioned, origin binding, great. No shared secrets on the server, great. But I think the third item here is what makes this compelling, because we've had phishing resistant sort of mechanisms, but they weren't really usable. And I think what's happened in the industry in the last couple of years has created an environment where all of us can use this with the software we have on our phones, on our laptops, in our browsers. And that is what makes it so compelling. So the FIDO Alliance is kind of responsible for getting us here, and it's not like a company, it's a standards body, a tech alliance, and it's not an American thing. I want to point out that this is a tech alliance with a lot of American companies, but there are other companies. So yeah, obviously the key ones are Apple, Google, and Microsoft. They're the ones that are writing our browsers, our operating systems, the software that we use every day. And they are all part of the FIDO Alliance. But we also have other passkey providers, password managers. We have Dashlane, we have LastPass, we have 1Password, maybe a couple of others. And as you can see, a lot of other tech companies that are interested in developing phishing-resistant solutions for their own services as well. So just to be clear about what the standards are, so you may have heard of WebAuthn. So WebAuthn doesn't actually live in FIDO standards body. It's actually been kind of Trojan horsed into the W3C, and that allows exposure to all the browsers and the operating systems, and that's where it was developed over the years. I think in 2019 it really became compelling once Apple and everyone else started to implement it. And what the FIDO Alliance does, this is one of the standards it develops, and this one is specific to passkeys, is what's called client to authenticator protocol. So if you have a YubiKey or a Talis key or a Titan key, the actual interface between what the browser's doing through the operating system to the key is this client to authenticator protocol. So that obviously needs to be standardized for interoperability. Otherwise, you wouldn't have all these developers building these keys. Otherwise, it'd be all proprietary and whatnot. So if you were following the news around passkeys and FIDO in 2022, I think it was International Password Day, nice marketing moment for these companies. They all committed their support for FIDO2 authentication. And that was, I think, the moment when Dashlane and other password managers were like, "Ooh, what's this?" Because we'd heard about FIDO, we were all well aware of security keys, but it wasn't something that was going to be like mass adoption. But this, when you get these three actors in the game, you start thinking, oh, this could become mass adoption. And then where does it leave us if we're just, password managers, which obviously, we heard about dark web insights and Have I Been Born? Dashlane and other products do actually do a lot more than just password management, but if this is a new type of credential, it's really interesting for us to get in on it. So I'm going to quickly talk about, we looked at the standards, but what do the standards actually allow? And what we've seen in the industry come up with is different flavors of phishing-resistant credentials. And ones the security folks amongst us will be familiar with as security keys. But what was really, let's say, announced, I would say, in 2022 was the idea that the private key doesn't have to stay in the device. It can actually get encrypted, pushed to the cloud, and then brought down to all your other devices. That was what would make it, let's say, ready for mass adoption, because you can't imagine everyone's going to buy a security key. And in the middle, there is an alternative, which is a local device credential. So like in the past, I could create a credential that just lives on my Mac or just lives on my Windows, which is actually what happens on Windows. But then what happens when you go to another device? You can't really use that credential. So Sync Passkeys really changed the game, but it also introduced, other issues. So some would argue, well, Sync Passkeys aren't as secure as security keys. But the key thing is, Sync Passkeys are still way better than where we were with passwords. And here are some of the example products. So almost all the third-party providers, Dashlane, 1Password, Bitwarden, are doing Sync Passkeys. iCloud keychains, so if you're completely in the Apple ecosystem, you can use it's not called iCloud keychain anymore, it's called Apple Passwords, which is kind of ironic. So that runs passkeys as well. And Google Password Manager is also a Sync Passkey provider. And in terms of the local device passkeys, so Windows, so far, they haven't really developed any Sync Passkey solution. So if you have a Windows PC, that credential is staying in the TPM of that device. I think they will eventually, or maybe they have already, I'm not following it. They may have adapted their Windows Authentic or Microsoft Authenticator app that they have on Android and on iOS to also do passkeys, but that's through that app. And I put in brackets Chrome or macOS. So if you are a Chrome user on macOS and you've tried to use passkeys, you'd notice that it doesn't sync with Google Password Manager. It actually stays in the Chrome profile. It's kind of a temporary solution because there's a bit of a weirdness going on with Apple. So eventually they added the ability to sync in iCloud keychain. And I believe they eventually, later on, they're going to add Google Password Manager support on Chrome on Mac. So some of this stuff is still being developed, but you can use passkeys. And some companies are building mobile SDKs, so you can have device-bound keys as well. And security keys we all know about. So here are the broad providers. So if you're a website that's developing passkeys, you have to think about how you represent these things to your user, because your user needs to see, oh, I just created a key, it's in Dashlane, or it's in my iCloud keychain, etc. So if you're following some of the chitter chatter amongst the people that are let's say skeptical about passkeys, one of the hot topics that have come up is, well, this is just a way to do vendor locking. And why do we hear that? If you use a password manager and you use passwords, you can export your passwords. And what you do is you create a CSV file with all your passwords in a plain text file, and you just leave that in the trash can or on the desktop, waiting to be malwared out of your machine. So all the passkey providers have not really wanted to put private keys in a CSV file. That doesn't make sense. Like, we create this brand new standard, and we're just going to put the key in a plain text file, that's not cool. So none of the key providers are doing passkey export because A, we don't want to do CSV files. And the second thing is there's no standard. Today, there's no standard even for the CSV file. So if you use any password manager and you export all your passwords, you compare all the CSV files, they're doing things differently. Dashlane will do, maybe first column URL, second column password, blah, blah, blah. Others will do other things. So each product needs to understand what the other product is doing in order to have interoperability with import export. It's a mess. And our developers, find it a pain, and I imagine every other password manager also finds it a pain. So actually what Dashlane and 1Password and Google have been working on for the last year or so is a couple of new standards that have just been published as working drafts, which is a credential exchange standard. And there are two standards. So the first standard is, well, let's have a format that everyone understands, for not only passkeys and passwords, but also all the other data types that we put in password managers. We also put in credit cards, addresses, secure notes, and we can standardize this stuff so it's easier for us to exchange this stuff. Users should be able to leave your product and start using another product. Especially if some other product got breached, it would be great if those users left that product. Don't know who I'm talking about. And then there's a protocol. So that's the format, but you also need a protocol. How do you actually get these two products to talk to each other in a way that the user doesn't have to do much? Because we don't want the user to go back to export, type in a password, a weak one, and then import again. Even if it's standardized, that's not ideal. So what we actually did is look at how some of these, how things work today with things like TLS, and look at like Diffie-Hellman key exchange or key agreement. And we built a standard around that. And we're using a up-and-coming standard called HPK, hybrid public key encryption. It's just a way to put a crypto system around these sort of hybrid crypto things that allow us to just have some future resilience around cryptographic agility. Once I think we're going to hear about post-quantum crypto, and that's going to be it's going to be a good standard. It is a good standard. It's up and coming. It will be finished by the end of the year. And this is how it's going to work if you're on mobile. We're still figuring out things on desktop on Chrome, but we actually did a proof of concept with Google, which we presented to the Fiber Alliance a few weeks ago. So imagine you've just downloaded your new password manager app. You'd go to the import section of it. You'll smash the import button, and then the operating system will come up. And the operating system will, at this stage, know about the other products that can export, this export exchange. So you'll select the product that can do that exchange, and then that'll switch to the exporting app. That's the step 3. And then there you'd have to authenticate, maybe do Face ID, type your master password, and you're like, hey, do you want to export your stuff? You hit go, and even at this stage, this app will know what the other app is. So there's some sort of control going on. And when you hit export, that's it. Your data will end up in the importing app. So under the hood, what's going on is essentially Diffie-Hellman. There's a public key going from app 1 to app 2. There's a symmetric key being generated, and then the public key for the app 2 is going back to app 1. The same symmetric key is generated, and then we can decrypt the payload. So for the user, it's going to be really simple and great, and this is going to solve all this CSV file mess. So we're still early days, but we do see some great results from some case studies. I've only mentioned a couple here, but there are different case studies. Even Dashlane's put out a case study that Google published. So Kayak, if you use Kayak for traveling, they actually have gone all in on Passkey. So when you create an account, it will be Passkey first, meaning when you create your account, you're not even asked for a password, you go straight into the Passkey flow. And what they've noticed, other than obviously the security benefits, is just that signing times is just one click. It's just, you're not sitting there trying a password, going, forgetting it, hitting the I forgot my password link. It changes the pace at which users sign in. So the bottom two charts are from Google, and they've seen that the success rate of Passkeys is way higher. And you may ask, why isn't it 100%? And it may be because, this was like a year ago, that maybe that the client that the user's on isn't quite up to speed with Passkeys. As you can see, passwords are typically pain points for users where they're just forgetting their password or making a mistake. And they also see a speed uptick on the use of Passkeys. So where are we with passkeys? And this is taken from crossing the chasm type of diagram, just to give you a sense of where we are. We're at the early adopter phase. There's still a long way to go. Many people outside of the tech bubble probably have never heard of FIDO, have never heard of passkeys. They shouldn't really know about FIDO. Maybe you can argue they shouldn't know what a passkey is. They should just be clicking and suddenly magic is happening and they're not even worried about it. So Apple and Google are investing huge amounts of money into getting passkeys up and running. So Apple, if you're following WWDC, which is their annual conference, they recently announced that they'll just have a mechanism where passkeys are generated in the background. You won't even have to set up a passkey flow if the website wants to do that. So you'll sign in with a password. Magically, there'll be a passkey generated. The next time you come along, there'll be a passkey being used. So you can see that they're really thinking, like, how do we get everyone onto passkeys? So just to summarize, passkeys are really the only viable protection against phishing. There are other solutions that can work against phishing, but this is the only one that's viable because of that universality. As you've seen, there are different flavors, there are different providers. Whatever password manager you're using, whether it's the system or a third-party provider, you most likely have a passkey provider in your software today. Data portability is going to be critical. People don't want to be trapped inside a product, especially like, let's say, even if you want to change, iPhone to Android, you need to be able to move the credentials. And if your passkey provider has been breached, you probably want to quickly move to a better one, and that needs to be possible. Early indicators show promise. We've not really seen any attacks on sites that fully support passkeys, and those providers have been very open about sharing that data. So for those that haven't tried passkey, just like I've been talking about passkeys, but what is it? How do I touch it? How do I see it? You can go to g.co/passkeys if you have a Google account. That will immediately take you to the passkey page. You can set up a passkey, log out and log in, and you'll see you won't need to type anything. Your biometrics will most likely be used, and that's it. You'll be using passkeys, and you'll be safer for it. That is it. Thank you very much for listening. Any questions? I know it's getting really hot in here, so maybe we can just run through a couple of questions.
How do passkeys work with multiple devices?
How do passkeys work with multiple devices? So if you have a synced passkey provider, as I mentioned, the way you create your passkey, the private key will be encrypted based on some sort of key, whether it's your password for your passkey provider or something else. It'll be moved into the sync fabric of that provider, whether it's Apple or Google or Dashlane. And then when you go to your other devices, as long as you've got a client there, it'll bring it down, decrypt it, and make it available to use. So it's essentially a synchronized private key. So if you think about like GitHub, you're using SSH keys, but imagine if that private key is now magically going to some, all your devices in a magic way.
Okay, thank you.
Hi, what would be the main pain points for organizations to start moving from passwords to passkeys?
That's a great question. So for those that didn't hear, Olga asked, what would be the main friction points or the challenges of moving from passwords to passkeys? Lots of challenges, but it really depends on the nature of your business and the nature of the software, and nature of your users as well. So obviously behind the scenes on the website side, it's more than just a table of password hashes now. Now you've got to have some software that does key verification, or let's say signature verification using public keys. You have to validate payloads coming and going. There are off-the-shelf solutions. A lot of most organizations will probably take an open source solution. Like Simple Web Authn is quite a easy one to learn about passkeys with, but there's also paid solutions. So yeah, the technology's there, but then the question is what about the user experience? The FIDO Alliance is not just setting standards, they also have a UX working group. So if you Google FIDO Alliance, UX working group, guidelines, they're putting a lot of money into researching on how to get the best passkey experience for RPs and websites. I think they've raised like $2 million from all these big companies to figure out the full surface of the passkey experience and write guidelines so people don't have to rethink everything, reinvent the wheel. So there are challenges, but I think increasingly as time goes on, we're going to see those experiences in Google and Apple, and we'll also see the guidelines of how to implement this stuff.
I think in some situations the passkeys can be worse. For instance, they are not as safe against malware as physical tokens like YubiKeys. So is there any, like, I don't know, work? I know this doesn't cover the majority of people. Is there like any work, something being done towards that?
That's a great question. So the question was, synced passkeys are not as great
Not
as...
even synced, local. If my computer has malware, the malware can just quickly, as opposed to convincing me to introduce the
Sure. I mean, there are a lot of protections around the private key. So, for example, you know, if you have a YubiKey or even a Windows machine, that private key is stored in the TPM. So getting access to that private key isn't possible. And typically there's a user verification element to the experience. It's not part of the standard, as in your biometrics aren't being sent to the website. It's not stored in anything. But there may be a step involved where you're challenged using the system biometrics or even a PIN code, a local device PIN code. So those mechanisms are there. In terms of like protecting the private key, there are initiatives and ideas of more elaborate ways to protect the private key, especially in a synced passkey scenario. But I mean, I would say depending on the type of malware you have, even if you have passkeys, there's a lot of things where it's game over. The curtains are coming down anyway. So this is more against like mass remote attacks where, as you saw with the phishing attacks, that's the number one problem today on the internet. People are just clicking, filling in forms, clicking next, and they're gone. So this is solving for that. And there'll be other solutions for other sort of things. Hope that answers that question.
I had one.
Yes.
And maybe you're going to help me with my presentation later on. I believe, but I want to hear it from you. Even with passkeys, this is a one-time thing. It's not like the mutual TLS. So you just provide your passkey once and you get the out token, and then you just exchange the out token with the server, right?
So actually, the standards here don't talk about session management at all. That's up to you. But there are initiatives like DBSC? I can't remember what DBSC is, but it's a mechanism to use local device. Essentially, how do you make a local device session token that is tied to your device, right? So if that session token gets exfiltrated, it's of no use to the attack. So that's nothing to do with passkeys. It's only focusing on authentication. Beyond authentication, what you do with the session is up to you. And that, as you mentioned, you may have to think about that as well.
She's going to help later.
Okay, thank you so much for all the questions.